Okay, just picking up where we left off on 11 from reviewing resolve by factoring. Again, throughout this video, make sure you try these before you watch the solution videos. It's going to help you a lot more for the test if you practice and think through. Even if you can't do all of it, just do part of it before you watch the solution. All right, so again, do that on 11 if you haven't already. Okay, so when you have four terms, right, we want to look for a DCF, but there isn't one. But if we group them, so when it's four terms, you're going to do factor by grouping and then pull out GCF. So out of the front, there's both a 2 and an x squared we can pull out. Leaves us with, let's see, x minus 1. Out of the back, you can pull out a plus 3, and we get an x minus 1. All right. Okay, and now things are going well because the two parentheses match, so we take whatever's in front. 2x squared plus 3, that's one of our factors. Okay, and then the parts that match make up our other factor. So times x minus 1. All right, and then set those parts to 0. So we could do 2x squared plus 3 equals 0, x minus 1 equals 0, and add 1. That'd be one answer here. And then the other two answers come from solving this, and we can actually use algebra steps here. They'll look a little bit weird. Minus 3 divide by 2, just getting x squared alone. So negative 1.5. All right, and then to complete this, I want to take the square root to cancel out the square. And so what I'll get is x equals plus or minus square root of negative 1.5. Okay, and I think we've done some simplest radical form stuff here. So all I'm really going to do here, because 1.5, we don't normally have a decimal there, but I'm going to pull off the negative part and make that I. So it becomes plus or minus imaginary square root of 1.5. Right, and that's two more imaginary answers, giving us a total of 3 answers for this x cubed. All right, solving another x cubed, right? And just a hint on this one is you've got to use the factor patterns. See if I have them in here somewhere. All right, so the sum or difference of cubes patterns, and these will be right on top of the test. So figure out which one of these two patterns you're going to use, and then start factoring using that. All right, so yeah, give it a shot, and then I'll go through it. First thing is we're going to use this factor pattern because it's the minus pattern between them. And then A and B come from sort of doing the cube root part. So like if I cube root this, I would get x. And cube root 125, I get 5. Right? And don't worry about being negative 5. This part is always going to be 5. And then the negative will come out because we're going to use this specific pattern. Okay, so now that we've done our cube roots of these parts to figure out a and b, we can say this thing factors, that whole thing factors to a minus b, so 5 minus x, times a squared plus a times b, so 5 times x, plus 5 squared b squared. All right, and then one of our answers, if we set that little thing to 0, we'll get an answer of 5. Right, and then we've got to solve this part, this cube part. We could try to factor, but on these questions, they won't factor. And in fact, it'll have imaginary answers, right? So on these, we're going to want to do our quadratic formula with a new ABC. So we're going to solve just this thing. And A is now going to be 1, B is going to be 5, and C is going to be 25. When I do quadratic formula, I always do this b squared minus 4ac, that part first. So I'm going to do 5 squared minus 4 times a times c. So 25 minus 100, negative 75. And then I just got to clean that up. So that's a radical underneath the radical. So we're going to do simplest radical form. So 25 and 3 for the 75. And then the negative part is going to become I. So I'm going to pull that apart, 3 things. So that gives us 5, an I, and a radical 3. Square root of negative 1 again is I. So our answers, if we compute our formula here, are opposite of B plus or minus that 5I radical 3 all over 2A, so just 2. And if the 2 evenly divided both of these parts appear, I would do it, but since it doesn't, I'm just going to leave it that way. So we have 3 answers of 5, and then these 2 imaginary answers. And that's largely one of the hardest things on the test, but you'll have these factor patterns and then also this quadratic formula. All right, I think we've done already ones like that. We've done like that. I think the only thing we need to review still then is what's called synthetic division. So I'll review that one more time with this divide question. Sorry, it doesn't show up super good, but this is dividing this polynomial by that polynomial. All right, so again, give it a shot before continuing. Okay, so synthetic division, you draw the little box, and into the window goes the solution. So if I was to set this little factor to 0, I'd have a solution of -4. Okay, and now I want to list my coefficients: cube, squared, x to the first, and constant along the top. So I have 1x cubed, 2x squared, and I have no x's plus 7. So that's what part of what makes this one tricky is you have to list them in order and have a 0 because of the gap. Okay, and then from there, the process is drop this number, multiply with the window. So 1 times -4, add those together, multiply with the window. -2 times -4 is 8. Add these together, it's 8. Multiply with the window. -4 times 8, -32. Add these together. All right, and then that's our answer. When we divide, we get this remainder, constant, x, and x squared. So I'm going to write all that out. So I have 1x squared minus 2x's plus 8 with remainder of -25. So when we divided those polynomials, we got a polynomial 1 degree less, right? We started with an x cubed divided by an x to the first, and we got an x squared. All right, I think that's it. If you have any additional questions, please reach out, and thanks for watching.